All right, so let's shift gears a little bit and let's start talking about inverse variation. So with inverse variation, it's basically just the opposite. So in inverse variation, as one thing goes up, the other will go down. Or if the first thing goes down, then the other thing will go up. So they're going in opposite directions. Now in inverse variation, we do still have a constant k, but our equation is going to be different. So instead of doing y equals k times x, we're going to be doing y equals k divided by x. Or an alternative form of that equation, if basically I just multiply by x on both sides of this original equation, I come up with xy equals k. So basically, if I multiply my two variables, I'm going to get the same constant every time. This equation, often easier to remember because it is so similar to the direct variation of y equals kx. However, this equation is often much easier to use in the context of the problems. So I'll try to use both throughout. You can kind of pick and choose which you would prefer to remember and which you would prefer to use. But usually that xy equals k is the easier one to use throughout. All right, so let's start off with some similar problems that we did with direct variation. So here it says, if y varies inversely as x, again, words telling us that it's inverse variation, and y equals 8 when x equals 4, find x when y equals 2. So you see this problem looks very similar to the ones that we just did with direct. The important thing is that we really pay attention to the words that are given telling us that it's inverse variation. Because instead of using y equals kx, I have to use the inverse variation equation. And in this case, I'll use the version xy equals k. Very important that you use that correct equation. Because if you don't, you're just going to be doing a direct variation problem, and it's not going to be a correct answer. So in this situation, we're going to substitute 4 in for x and 8 in for y. So we come up with a k value of 32. We're now going to go ahead and rewrite our equation. Again, now that we know that k is 32, I'm going to write xy equals 32. So this is saying basically multiplying any x and y value, I have to get 32 as an answer. So as we go to solve this, if we know that y is 2 and we're trying to find x, we can just input 2 for y and solve for x. In this case, we come up with 16. So when we look at this relationship, I'm going to spend a little bit more time talking about this because this type of situation really is new for you. So when we look at this, if I look at the y value, so notice how we started with a y value of 8, and then it decreased to a y value of 2. With inverse variation, we're going to see the opposite relationship with our x. So x started as 4 and then increased to 16. You can get even a little bit more detailed here, and you can see that the y was divided by 4, the x was multiplied by 4. Sometimes that relationship is really clean and easy, like in this case where it's 4 that you're multiplying and dividing by. Not always the same in every situation. So just some things to think about as you start working through these inverse variation problems.